Hello, my name is Tom Holoien, and I'm a graduate student in the astronomy department at The Ohio State University. I'm a member of the All-Sky Automated Survey for Supernovae, or ASAS-SN, and today I'll be discussing one of our recent discoveries, which is presented in our paper titled ASAS-SN 14AE, a tidal disruption event at 200 megaparsecs. The ASAS-SN survey scans the extragalactic sky visible from Hawaii roughly once every 5 days in the V-band using 4 14-centimeter telescopes, looking for supernovae and other bright transients. Our transient detection pipeline was triggered on January 25, 2014 by a source located less than 0.2 arcseconds from the center of a spiral galaxy at redshift 0.0436, corresponding to a distance of about 200 megaparsecs. Archival data from SDSS, 2MES, and WISE indicate that the galaxy has no signs of AGN activity and only some signs of recent star formation. Using an O3 emission feature in the host spectrum, we place an upper limit on the black hole mass of 10 to the 6.8 solar masses. We announced the discovery of this transient in an astronomer's telegram and named the source ASAS-SN 14AE. While initially we thought this could be a supernova, our follow-up data soon led us to believe that this was actually a tidal disruption event, or TDE. A TDE occurs when a star's orbit brings it within the tidal disruption radius of a supermassive black hole, pulling the star apart. The disrupted material is then either ejected or accreted onto the black hole, as shown here. Observationally, TDEs should show spectral characteristics and light curve evolution that would distinguish them from both supernovae and AGN. We requested and obtained swift space telescope observations of the source in the optical, UV, and X-ray. We supplemented these with both photometric and spectroscopic observations from a number of ground observatories in optical wavelengths. These observations span roughly 3 months after detection of the transient, and we constructed a light curve with the photometric data, which is shown here. In this figure, data in different filters are shown in different colors, with colored stars indicating host galaxy magnitudes in the same filters. The light curve shows the transient was much brighter in the UV and bluer wavelengths than the host. Followup Spectra, shown here at various epochs, corroborated this picture, showing a strong blue continuum that grew weaker over time and broad emission features, particularly H-alpha, that remain strong even in the most recent epoch and are not present in the host galaxy spectrum, shown in black. Using these expansive follow-up observations, we compare ASAS-SN 14AE to both supernovae and AGN in a number of ways. First, we used archival data to fit the host galaxy SED and derive host magnitudes in the swift UV and optical filters. We then used these to examine the host subtracted magnitudes and colors of ASAS-SN 14AE. This figure shows ASAS-SN 14AE's swift UVM2 minus UVW1 and UVM2 U colors compared to those of SN 2008ES and SN 2012AW, both core collapse supernovae. While SN 2008ES becomes redder in UV minus optical and bluer in UV minus UV, and SN 2012AW becomes much redder in both colors very rapidly, ASAS-SN 14AE remains at a relatively constant color over 80 days since discovery, indicating it would be highly unusual if it were a core collapse supernova. Next, we fit blackbody curves to the transient's host-subtracted SEDs and used the best fit curves to model the temperature and luminosity evolution of ASAS-SN 14AE. This figure shows the blackbody temperature evolution of the transient. For epochs with swift observations, shown as filled points, we fit the temperature as a free parameter, and for those without, shown as open points, we fit it with a prior, which is shown by the solid line. As you can see, the blackbody temperature of ASAS-SN 14AE remains relatively constant at roughly 20,000 Kelvin throughout the period of observations, which would not be expected if it were a supernova. In contrast, the luminosity drops steadily over this time. Here, the solid line shows an exponential fit, which fits the data better than popular power law fits for TDE light curves, which are shown as dashed lines. Integrating the luminosity gives a total energy of 1.5 times 10 to the 50 ergs released by ASAS-SN 14AE, only requiring about 10 to the negative 3 solar masses of material to have been accreted by the black hole. Lastly, we compare spectra of ASAS-SN 14AE to those of AGN and supernovae in literature. This figure shows early phase spectra of the source and comparison objects, and ASAS-SN 14AE appears to most closely resemble the luminous Type 2P supernova ASAS-SN 13CO, and does not resemble the AGN SDSS J1540-0205. In contrast, this figure, showing late phase spectra, indicates that at later times ASAS-SN 14AE resembles the AGN more than the supernovae shown, particularly in the broad H-alpha feature. The supernovae become redder much more rapidly than ASAS-SN 14AE, consistent with the previously shown color plot. ASAS-SN 14AE is significantly different from both supernovae and AGN in its color evolution, its temperature and luminosity evolution, and in its spectra. While we cannot completely rule out highly unusual AGN activity or a very strange supernova, it appears that the most likely explanation is that ASAS-SN 14AE is a tidal disruption event. However, given the exponential luminosity decline and the apparently small amount of material accreted onto the black hole, this event may be better explained by the tidal disruption of a giant star's envelope rather than by the complete disruption of a main sequence star. At redshift 0.0436, ASAS-SN 14AE is the lowest redshift TDE candidate ever discovered at optical or UV wavelengths. Now that ASAS-SN is fully operational in both hemispheres, we expect that it will discover 1 to 2 of these events per year going forward, making it an invaluable resource for studying both TDEs and other rare bright transients in the future. If you would like to know more about this work, please see our paper, which is posted on the archive. Thank you.